No signals. Come on. See, more than about a minute and no signals. No video, no audio, events log. What to do? Yes, now it has come. Good morning. Good morning. Namaskar. Good morning, everyone. This is Engineer Suraj Singh speaking from Bharat, India. On this day, July 20, 2021, Tuesday. Quality and safety in life. Title of talk being Field Engineering, Civil Field Engineering, Quality Structure, COVID and Health, and Engineer's role towards both, designs, construction, methods, contracts, organization, communication, coordination, etc., etc. Quality being on top. This is our daily requirement because we have certificates, we have honors, we have professional status, we have all required status to do what's required to be done. Are we only having a status, or we have to give back to society quality and also safety? Are we doing concrete work towards that? And that's particularly I'm talking about my country, my motherland, my workland, where I was born and probably from where I shall live forever. Bharat, India. Particularly I am concerned about that. This certificate tells something that I am a responsible person, and this also tells something that I am a responsible person, and this too announces same. But is it for only announcement, or it has to do something for life, for quality? Every day I talk about this, and maybe some people don't like it. Some people maybe waste our time. It takes time to explain quality and safety every day. We understand that. Okay, we understand that, but I do not understand that. I don't find safety in reality, health in reality, and you can say environment, required environment in reality. Quality does not exist. I openly say that, because until people are quality one, quality cannot exist. Quality exclusively depends upon will of individuals, will of people, will of organizations, and will of all those who are involved. There may be people, there may be many people, there may be many telephone connections, there may be many telephone talks. No media is left which is not involved. But still, I don't find quality. Where is this? Where is this baby missing? I don't know. It's a responsibility, or it's just a declaration. I don't find quality in general. Maybe 1 or 2% systems give quality. If it's only that, I ignore it. On an average, in general, quality, I openly can say, has been missing from our land, and generally in all branches of production, manufacturing, engineering, or other sectors. Because if manufacturing, engineering, and health miss something, There is no way that others cover it. Others can't cover it. Quality and safety absence means life is not safe, life is not qualitative, there is danger to health of people and safety of individuals and society cannot be kept intact. Environment cannot be used for good. You have to agree on this that we lack in safety, we lack in health sector, and we lack in preservation or upkeep of environment. Situation of health sector in ours is too bad. It's beyond even imagination. We could not even imagine what health is now in our country. COVID-19 has exposed our rubbish system. COVID-19 has exposed our dirtiest health system in our country, which is not helpful for 75 to 80% public who are poor, who depend on normal or supportive health system. There are 10 to 20% people in this country who can afford everything, and they are affording, but poor are not getting any benefit of that. Why it is? It is all because of lack of quality system, lack of policies, lack of governance, and on top of all, lack of will of our society, our people. When people become sleeping lot, this happens. We are like lot parking, car parking, where all cars are parked and nobody cares, only some guards are there, and even if they are not there, nobody can do anything. We are all silent society people. We have no soul power to speak against system, against governance. We have no power to speak because our souls are weak. Our minds are weak. Our tongues are locked. Our mouths are locked. Our lips are locked. Our eyes are closed. That's what is happening. It is a country of 130 crores or 1300 million people, and out of them there is no voice. There is no consideration for safety, for health, for environment, and for quality. This is called sleeping society of Bharat, India, where there are crores of educated people, crores intellectuals, including doctors and engineers. Doctors, those who work in limited sector, I mean to say in public sector, they may do something for people. Otherwise, other doctors who are not linked to people or public sector, they are linked to high-fi hospitals, 5 to 7 stars hospitals. They are all behind system, behind procedure, how to generate money for their richest owners. Quality does not mean only in engineering. Quality means it should be available everywhere in all sectors of our lives. Manufacturing, production, engineering, construction, transportation, dealing in public, everywhere it should be. No words can replace quality. No polite system can replace quality. No talks can replace quality. I can say, if quality is not possible to be produced, to be delivered, whatever systems you have, all systems are important. No meaning of communication, no meaning of coordination, no meaning of whatever you can consider if every process is qualityless. I may be called mad, I may be named quality phobic, I don't mind because I am talking on behalf of people, I'm not talking on my own behalf. Sometimes when you have to correct some bad item, you have to beat it also. Sometimes you have to teach some bad student something, you have to beat that student. That is practice. And that is required because misguidance should be avoided, mislead should be controlled, and where there is complete mislead in our system, overall quality system, we have to take care of this, or else it will go on further on path of deterioration, on path of, you can say, darkness. Quality existed sometime long back, but now quality exists only in money earning, quality exists in lying statements, quality exists in publicity, quality exists in decoration of individual persons, quality exists in show business, quality does not exist in reality. It's not question of production alone, it's question of mindset, it's question of individual set. How do I behave? How does someone else behaves, conducts? How does some company behave? Means if you consider one point, certainly that consideration links to many points. That is a kind of automatic loop is created. Individuals are not interested, or they may be ignorant, or they may not have required information. This can happen. Even then, we cannot say that we are not to worry about quality. It's individual actually that gives quality. It is a group of individuals that deliver quality. It may be in whatever work. If we can't get quality, we lose everything, and we have been losing everything. You cannot say today, stand in and say which product is best one. Publicities are best one indeed. Advertisements are best one. Lying statements are best one. They are best. Nobody can deny this fact. But do I depend on publicity? Should I recommend something based on advertisement? No. Should I spend something on some film stars recommend something, or some politicians recommend something? No. I have to believe in something. If that something is for me, I pay money and I get back my money through good material, qualitative material. But it doesn't happen. Nowadays, it may be a small group of company, or it may be very highly reputed companies. I don't find any difference between them, among them. They are not quality conscious. They only give some discount and befool people. Why? It may be company from USA or from China. It may be company from elsewhere. I don't find any quality character in them. No quality character in them, because quality means in writing there is quality. Quality means in lip service there is quality. Quality means in only you can say design of performance comments is only quality. They will give you little service and then they will ask many questions. Please go to this site, please go to that website and evaluate our service. Why should I evaluate your service when your product is rubbish? If product is rubbish, you are rubbish, simply speaking. Because I pay money. I did not buy anything free. You did not give me anything on charity. And even if you give me on charity, it should be workable. I consider all you people who do not believe in quality, who do not believe in quality system, who do not believe in trust, these are all cheaters. These are all rascals, whoever they are. I should say, in whatever bad word these people they are. They may be international company or they may be national company. They are all rascals. I experience this very much. I'm not their slave, but because I'm paying, I pay you, you give me back, and if you don't do that, I'll kick you. I'll give you abuses to you. I'll use whatever word I can because my blood burns. I give you my hard-earned money to get that material, and you don't care for your customer. For delivery, for selling, you want to say, I give you free delivery for purpose of sale because you have to get money. You have to dispose your kachra, your rag, your rubbish, your scrap. And you say, I'll give you free service of delivery. But when it comes to question of that your item is bad, it's not quality one, it's not performing, you have no guts to replace it using same method. You don't even respond correctly. And you say, go there and go there and go there to our service center, this and that. Why don't you take back the same way? This means you are only interested in sales, you are not interested after that. That's what I say. People are cheat. People are only interested in promotion of business. They are not interested to serve people qualitatively. And this is kind of system now that ads are very good, publicities are very good, paperwork is very good, SMSs are extremely good because they keep on sending a little service, a little information, they will send SMS. They're trying to show that they are very serious, but in fact they are not serious. It's very easy to program something and automatize that, and people think they are very serious. In fact, they are not serious. They have forgotten seriousness once they enter into field of, you can say, automatism. So that way automatism harms society. And we know without quality compliance, without safety, health and environment follow-up, nothing can work. And this is what is happening. Quality has to be complied with, but it's not compliant. It's only in drains. It's only in advertisement service or publicity, or it is only on papers. They know people have no time. For every small item they cannot come to you again and again, and nobody will question. They may say that. But it's my duty, it's duty of every consumer, every customer to fight with these people. I should say fight because I am very upset with some high profile companies like HP and like their agent VLE, Bajar. These all people are, you can say, anti-people, anti-public. These all people work against quality system. They may be having quality system. They send you good packing, but their minds are also packed. It's packed mind, packed quality, packed company, qualityless people working in our country. They should die in fistful water. They have no shame. I don't want your rubbish answers. I don't want your nonsense, because you are bloody kids of bloody people. You don't respect quality and you don't respect people. You have soul and that's it. You got money and that's it. You spoiler of our country. You are dirt on our face. And our government is another dirt on our face. There is no one to take care. No one. Government is negative. There is no government. It's void. I can simply say that. Because my heart burns. My mind burns. My money is cheated. My money is robbed. And then you have to move here and there. Because you don't have time. You spend money on transport. You go to them. You request them. Bloody hell, I will request you. You robber. You dirty guy. Why should I do that? I am a customer. You should respect me. Because of me you survive. You are a qualityless people with system of quality on papers. You are nonsense companies, nonsense organizations. Believe me, had I been power, I will cook you, I will break your head. I'll broken your heads. I broken your legs. This much anger I have with these robbers of people of this country. It doesn't matter how much money I pay whatever you demanded. And you should do service. You did not do that. You harass your customers. So what is that? It's called robbery. It's called antisocial work. Your quality is bad, it's my fault. Your product is bad, it's my fault. It's your fault. And if it's your fault, you have to take care of that. But you want. I don't need your polite answers, and I don't want to be polite for this purpose. Because politeness doesn't work. I am paying you and you have to pay me back. That's all. Or I break your head. That's another solution. Simply speaking. How far can I digest? Yes, I don't have any sense of speaking and writing because you are a senseless person. And if you are a senseless person, this is only way to teach you a lesson. You are animal. Simply speaking. You are not human being. If my friends, you mind it, you mind it. I can't hide facts. I am very much against those who try to befool consumers, who try to befool people of this country, whoever they are. They may be business people, they may be industrialists, they may be vendors, they may be political leaders, whoever they are. They may be doctors, they may be engineers, whoever they are. If they want to befool, they don't want to care, we don't care. It's like that hit. I will hit you. If I see you, I will kick you. That's what I say. I'm very much against those people who befool consumers, thinking it's small money who go behind. It's your product. You should respect your product. If your product doesn't perform in beginning itself, new product doesn't perform, what should I do? You know how much anger, degree of anguish I get? If I get delivery of a product after payment, I can't say anything to courier boy because he has nothing to do with that. His job is to deliver. When I open that product and pack it and try to use it, it doesn't work. What should I do? I don't know anything else except to be anguished, except to write to them. And if they don't respond properly, what to do? That's my question to everybody. Is your money free? Are you doing charity for companies? Is your money robbed money? You didn't work for that money. You didn't earn that money. And if that money doesn't give you product, what shall you do? Means there is a difference now in online shopping and in physical shopping. I think online shopping is not reliable nowadays. Better you go to shop and buy it. At least you can interact with shopkeeper. You can catch hold of him. It's very difficult to catch hold of these companies when you buy online. I bought laptop online. It was long back. That time maybe people were different. It worked. But nowadays, I think you should avoid online shop because these people's mind has been online. Actually speaking, these people are only online, they are not people. I can't consider them human beings. These people are machines. They think computer shall automatically answer. This is really a poison in our society. We have become slaves of online. We have become slaves of these robbers. These all online robbers, I should say. I don't want concession. I don't want free home delivery. In that greed, I spoil my money and then run from pillar to post for these people because they just want to talk on mobile. They just answer you, that's it. Do this and do that, as if I am paid by them. Bloody fool these people are, stupid these people are, cheat these people are. Every word I can use for them because they deserve it. I am 67 years, but I am very angry for this. These people don't respect anyone. I am sorry to say, this is not answer. If somebody tells you, I am sorry to say, I kick that person. You are not sorry. Don't feel sorry. I want the product. That's all. You did not say sorry when you got money. You did not say anything that I am sorry I got your money. You got my money. Give me product. Simple. There's no other relation. You are not my family member. I'm just paying you. Give me that. Or replace that immediately. If you are a good person, if you are a good organization, replace it. I don't want to come to you. You come to me and give me. That's it. Yes, if product is used for say a couple of months and then something happens, I agree, but I have to go to service center or I go to somewhere else. But a product in its when I want to use it, it's not working, it doesn't work. And then you say go to service center. Why did you deliver me that non-performing product? This means there is no one to check to make sure that product works when you deliver it or when you dispatch it. You just sign someone, okay, it's checked. Means your signature also or your passing that point is also no meaning. It's no meaning at all because you did that formality and packed it. When you pack something for delivery, it's understood that you checked it, you verified it. It's your fault if you didn't verify and you harass consumer. This means you actually do work against your customer and you ask for customer satisfaction. Then you ask for reports. How is our product? Your product is rubbish. Your product, if I buy two products, one works, one doesn't work. For me, it is 50% rubbish. Okay, one works, one doesn't work. And 50% rubbish means a failure because I did not pay you 50%. I pay you whatever you demanded. We have to understand that. This is clear indication that quality system does not exist. Even in electronic world, even in IT, it doesn't exist. If quality doesn't exist, what exists? Monopoly? Only brand name? only way to cheat others? Is that just an inducement that you get free home delivery? I don't need this free home delivery. You charge me money for that. I don't care. Because when I pay 98%, I can pay 2% also. What's wrong with that? Because transportation or home delivery, I don't think it can cost more than 1 or 2% of cost of material. So I have to be clear in this. Don't try to cheat me. I am not fool. Safety and quality is my life, and if you play with that, you know, one day you shall be nowhere because you try to only make money, get money for your product. Yes, I would be very happy if you should have replaced it immediately. That was one option. When I send mail, you should have replaced it immediately. But no, it didn't happen. It didn't happen. I bought that product on 30th, or you can say on July 13. It's today 20 July, yesterday 19. There has been no solution at all. And I have to go to the service center, couple of miles away from here, where it's difficult for me to walk and I can't spend money for car. So I have to go and request these people. Such a bloody statement, such a bloody treatment it is. Means they can't send someone to replace that. What if you replaced it immediately, either yourself or through your vendor? I would have been at least happiest person. Okay, product was not good, but service is good. They care for customer. Say they neither care for quality. These companies, HP or otherwise, HP or their vendors, they neither care for product manufacturing, product quality, and they never care for customer satisfaction. Means they don't care for customers in real world, in practical world. Yes, they care on papers, they care on advertisements, they care on internet, everywhere they care. They will show everything their best, but that's not fact. COVID-19 is moving very fast. News, I think, news are not being displayed, not being released. Something is happening behind scene everywhere. I have seen very limited news, but in fact, news are suppressed. News are not allowed from many parts of world. England is an example which there's a criticality every day. US is also moving fast in COVID-19, but news portion is very little, in case missing. World is passing through very strong phase of COVID-19, Delta, Lambda or others, Alpha, Beta. But only solution these people have found, these leaders have found, not to provide input of news so that people do not know what's actually happening, and that's happening everywhere, including ours. A confusion has been created among people, and you know how people think, how people of world think, do they think? Everybody depends on communication, reading newspaper or sometimes fake television news. It happens. You can befool people of world, and our political leaders in our country, India, Bharat, they are experts in befooling. And people, everyone is not intelligent in people, maybe 1 or 2%. Others are followers, and that's what's happening. They trust what news comes in, and that's all. And that cases are very low, case load is very low. We have triumphed, or we will triumph soon on COVID. Such kind of lip service or news service harm society, believe me. Even if cases are low, we should be serious. but government is not serious, and in sequence people are not serious. So that's going to be very impactable, very much unbecoming factor in future, because we are not serious. We are not serious nowhere, neither in quality, nor in production, nor in safety, nor in health. We are not serious. We have lost lakhs of people. Lakhs of people. Government says 4 lakh something, I say 25 lakh something. There can be disputes. And fact remains the government lies, I know. All governments of world lie for COVID-19. You can lie, but world doesn't lie, people don't lie, people understand. Today, 98% people in Bharat, India, do not trust government, except some stupid people who have only one thing in mind, they trust. Otherwise, general people of this country do not trust government. Our government, currently Modi government, nobody trusts. And that's very bad point, because if you don't trust government, it's difficult. But government is like that. Government is inefficient. Government is visionless. Government has no worries for people. That's also a fact. Our government is not a government. It is just on papers. Qualityless people, qualityless government, qualityless individuals, qualityless ministers, qualityless prime minister, qualityless president of this country. Everywhere it happens. Everywhere. They just want their own interest. Nobody wants public interest. Nobody wants social interest. Nobody wants national interest. They are only interested in their own interest. This means we don't have good people in governance. We don't have good people in administration. We don't have good people in society, in nation. So it's very bad time. In fact, it's very bad time. And on head then is COVID-19. So you can understand what's our standard of quality and safety. Nobody cares for these. They only care for themselves, nothing else. The government should run, let public go to hell. They don't care. They don't care. That's also a fact. Now, we was talking of in safety, we were talking of radiography that we had to study. And before that, just going through this small paper, I was interested to deal with you with, you can say, with this very important paper document, you can say, safety report series number 13, radiation protection and safety in industrial radiography. We went through this. We scanned this document and talked of about this. This is reported by IAEA. They are author of this, printed by IAEA in Austria in January 1999. And this is Safety Report Series number 13, Radiation Protection and Safety in Industrial Radiography. This is title of this, Radiation Protection and Safety in Industrial Radiography. This is title of this. I had covered some topic from this and reached somewhere. You can see certain titles here, objective of radiation and responsibilities, like that. Then we reach somewhere. Objectives of radiation protection and safety is chapter 2, in which product protection objectives and safety objectives. Then we went through organizational responsibilities on chapter 3, And of course, there is definition of regulatory authority, authorization process, and all that. Regulatory inspections, enforcement, emergency, likewise, appointment of qualified experts, then appointment of radiation protection officers, appointments of qualified radiographers, personal information, instruction and training, personal monitoring, workplace monitoring, testing and maintenance of equipment, and then you can say this operational instructions, industrial radiographer workers, manufacturers and suppliers, tests, quality assurance program and client. Therefore, radionuclides used in industrial radiography. Types of exposure, and we had these, you can say, units. We are somewhere here. Yes, we are somewhere here. This system which I am talking with you is about radiography. Very, very serious it is. This is, you can say, this is gamma radiography apparatus, category 2, and we talked about this last time. Then we went to dose rates for classes of containers. This is for class portable, that's P is portable, M is mobile, F is fixed, and these are dose equivalent rates. That is at 1 millimeter from external surface of container. These are dose rates, and we discussed with that, right? Now we are on page 35 last time. I think 2 more I covered. I went down further because of heavy rain that time. This panoramic radiating tube assembly with conical anode. We discussed about this also. Then we also discussed X-ray radiography equipment, that is direct radiating portable X-ray tube assembly. So we were at accelerators last time. We were at accelerators. We were there discussing. Accelerators can be used to generate high energy X-rays. That is, accelerators can be used to generate high energy X-rays. Typically 5 MeV for radiography. Radiography examination requiring highly penetrating radiations. Accelerators can be used to generate high energy X-rays for radiographic examinations requiring highly penetrating radiations. If object to be radiographed radiograph fits into enclosure. If objective radiograph fits into an enclosure, then X-rays can be generated. X-rays can be generated by large accelerator. This can be a linear accelerator housed in a shielded room adjacent to shielded radiography enclosure. Radiographic examinations of large structures such as bridges are done on site, and accelerators for this type of work are smaller, usually cyclotrons. A mobile accelerator may be mounted on a large vehicle. A mobile accelerator may be mounted on a large vehicle, namely truck, with accelerator head being mounted on a gantry to enable positioning of radiation beam. Positioning of a radiation beam. A portable accelerator can be transported in a small vehicle. Figure 9 it says that is portable accelerator, and that is I think figure 9. Portable X-ray Betatron. Portable X-ray Betatron accelerator this is, and here is this. Figure 9 can be transported in a small vehicle, namely car, and carried into position by radiographers. Portable accelerator weighs approximately 100 kg with ancillary equipment, controller, control panel, warning signals. This is ancillary equipment, ancillary controller is there, control panel is there, warning signals being of similar weight. Then underwater radiography equipment. For radiography underwater, for conduct underwater, exposure containers are to be provided with additional safety features. Necessary features include a depth rating stating maximum depth at which container may be safely used. Means a depth rating stating maximum depth at which containers may be safely used. Seals that either prevent entry of gas or water into parts that are not designed to withstand them. This is seals that either prevent entry of gas or water into parts that are not designed to withstand them, or if designed to cope with water and gas, allow them to escape during ascent to surface. A wind out category 2 containers, wind out, exposure or shutter, control mechanism which can be operated outside control. Let us see, it's not clear here. Alright, no problem. Let us read first. A wind out category 2 containers, expose or shutter category 1 containers, a control mechanism which can be operated outside control area. Now, pipe crawler equipment. Pipe crawler is this. Pipe crawler equipment. Pipe crawler equipment is used to radiograph welds on pipeline. Wells on pipeline. That is pipe crawler equipment. Machines carry either an X-ray tube, assembly, or a gamma source on a mobile carriage which crawls along inside of pipe. They are powered either by batteries on carriage, an internal combustion engine, or trailing cables from a generator. Crawler is activated and controlled by radiographer from outside pipe using a control source which normally consists of a low activity sealed source mounted in a handheld device and collimated. Means crawler is activated and controlled by radiographer from outside pipe using a control source which normally consists of a low activity. You can say crawler is activated and controlled by radiographer from outside pipe by using a control source which normally consists of a low activity sealed source mounted in handheld device and collimated. Radiation from control source is received by a detector on crawler. Typically, control source is moved along outside of pipe. Control source is moved along outside of pipe to initiate crawler to move in desired forward or reverse direction. Control source is moved along outside of pipe to initiate crawler to move in desired forward or reverse direction. Control source is held against outside of pipe or reverse direction. Control source is held against outside of pipe to make crawler stop and wait, and an exposure begins automatically about 10 seconds after control source is abruptly removed from pipe surface. Let us repeat. Control source is held against outside of pipe to make crawler stop and wait, and an exposure begins automatically about 10 seconds after control source is abruptly removed from pipe surface. Some X-ray crawlers are fitted control source is held against outside of pipe to make crawler stop and wait, and an exposure begins automatically about 10 seconds after control source is abruptly removed from pipe surface. Some X-ray crawlers are fitted with a low activity telltale radioactive source to help to identify crawler's position in pipeline. Pipe crawler and control source. Pipe crawler and control source are to be prepared and transported in accordance with requirement of IAEA safety standards, series number ST17. A gamma pipe crawler is shown in figure 10 and 11, shows general construction. Real time videography. Real time radiography is a variety of exposure devices are in use or under development for special applications in order to keep pace with faster welding techniques and commercial. We'll discuss this meanwhile, and you can just stay on this, touch on this. I'll be back in a couple of minutes. Meanwhile, you can just concentrate on this. Alright? Just concentrate on this, please. So real-time radiography, we're talking radiographer, we're talking real-time radiography. A variety of exposure devices are in use under, you can say, that a variety of exposure devices are in use under development for special applications in order to keep pace with faster welding techniques and commercial you can say production needs. Real-time radiography, which is also called fluoroscopic imaging. Fluoroscopic imaging uses digitally processed images displayed on a high resolution monitor instead of on conventional X-ray film. X-ray tube head or exposure container is mounted diametrically opposite a radiation detector. Objects to be radiographed are brought in front of exposed source by using a conveyor system or source, and detectors are rotated around object by a computer controlled motor. Both methods produce a digitized image on a screen. Person interpreting radiographic image views meter on several monitors and must decide to accept or reject each image before system proceeds to next frame. A real-time system allows radiography of large cast housings as shown in figure 12. Real-time radiography radioscopy of a bridge. Let us see now. First of all, we'll do it for this cross section of pipeline crawler. Here is of course it's pipeline. This is film, and this is iridium 192 here, iridium 192, and there is electronics. This is control isotopes, and this is detector. There's batteries, electric motor. There is a wheel, you can say, gearbox. So it's gearbox, it's electric motor. It's a kind of vehicle, you can see. And batteries here, and this you can see load shielding here. Drive motor for source, and here's radium 92, and this is fell here. This is cross section of pipeline crawler. A variety of exposure devices are in use or under development for special applications in order to keep pace with faster welding techniques in commercial. And here is for bridge, real-time radioscopy of a bridge. This is column, north column, south column, doesn't matter. No, north column, south column, north and south. And here is carriageway, central wedges, etc. Detectors is here. Put in here. This is a linear accelerator, you can say. Here is Harrison power detector, and this something, and this is, you can say, linear accelerator. Structure of this, and here is lorry, means lorry. We have to X-ray this one part of this. This is, you can see, like this, you can do that. So this is for bridge. Real-time radiography, radioscopy, this is carrying here all this, holding this lorry, and from here you can say production needs real-time radiography. It is also called fluoroscopic imaging. Fluoroscopic imaging uses digitally processed images displayed on a high resolution monitor instead of on a conventional X-ray film. X-ray tube head or exposure container is mounted diametrically opposite a radiation detector. Objects to be radiographed are brought in front of exposed source by using a conveyor system. So this is conveyor system. Our source and detector are rotated around object by a computer controlled motor. Both methods produce a digitized image on a screen. Person interpreting radiographic image views meter on several monitors and must decide to accept or reject each image before system proceeds to next frame. A real-time system allows radiography of large cast housings as shown in figure 12. So this hanger type here, this is a lorry, and this is what detector lies in. Neutron radiography. Neutron, although still in its infancy, neutron radiography is being steadily developed. Range of applications includes use of steady state and pulsed beams of neutrons. Pulsed beams of neutrons over a range of energies, subthermal, thermal, epithermal, subthermal, thermal, epithermal, and fast. In contrast to X and gamma rays, neutrons more easily penetrate heavy metals such as steel, lead, and uranium. But neutrons are absorbed or scattered in low density hydrogenous substances. Neutrons are absorbed or scattered in low density hydrogenous substances and certain materials such as hydrides, boron, plastics, cadmium, and gadolinium. Neutron sources include both radioisotopes and accelerators. Design and use of shielded enclosures, fixed facilities. Enclosures design use. Enclosures design and use. Experience shows that in general, industrial radiography is most safely carried out in a shielded enclosure. Use of an enclosure offers benefit of allowing other work in vicinity to continue without interruption and allowing radiography to be carried out as required. There is little doubt that where it's reasonably practicable to carry out radiography in a shielded enclosure, radiation doses resulting from work will be kept as low as reasonably acceptable. The radiation doses resulting from work will be kept LR as low as reasonably acceptable. Properly designed and operated shielded enclosures can help to keep radiation exposures of workers to 5 MSV or less per year. A shielded enclosure is an enclosed space engineered to provide adequate shielding from ionizing radiation. to persons in vicinity. General design principles are similar for all enclosures. General design principles are similar for all enclosures, although different characteristics are incorporated depending on whether enclosure is to be suitable for X-ray, accelerator or gamma radiation equipment. A shielded enclosure, which is designed for specific work and operated within its design limitations, can shield ionizing radiations in such a way that no control area is created outside enclosures. A control area within shielded enclosure exists during performance of radiography and may also exist owing to storage of radiography source alone. A supervised area may need be designated outside shielded enclosure. A supervised area may need be designed outside shielded enclosure where conditions do not constitute a control area, but where occupational exposure conditions need be kept under review. Specific protection measures and safety provisions are not normally needed for a supervised area. In establishing supervised areas associated with whatever shielded enclosures, operating organization taking into account nature and extent of radiation hazards has to delineate supervised areas by appropriate means, display approved signs at appropriate access points to supervised areas, and periodically review conditions to determine need for protective measures and safety provisions or changes to boundaries of supervised areas. I repeat, that is about supervised areas. In establishing supervised areas associated with whatever shielded enclosure, operating organization taking into account nature and extent of high radiation hazards has to delineate supervised areas by appropriate means, display approved signs at appropriate access points to supervised areas, and periodically review conditions to determine whatever need for protective measures and safety provisions or changes to boundaries of supervised areas. As applicable, siting, location, design, construction, assembly, commissioning, operation, maintenance and decommissioning of whatever shielded enclosure are to be based on sound engineering principle and have to बस तेरे की यार सल्फेज चला गया चली गई लाइट बस हो गया anyway delineate supervised areas by appropriate means, display approved signs at appropriate access points to supervised areas, and periodically review conditions to determine whatever need for protective measures and safety provisions or changes to boundaries of supervised areas. as applicable, citing vocations, designs, construction, assembly, commissioning, operation, maintenance, and decommissioning of any shielded enclosures are to be based on sound engineering principles. क्या करोगे यार? So here is what I say. This is emergency stop. This is actually shielded enclosure. You can say this is shielded enclosure. Effective interlock of equivalent. This is main entrance here. Main entrance. This is warning device, and this is emergency stop. And this is shielding. This is shielding. This is shielding, and this is shielding. So this is control panel outside. This is shielded enclosure. Here it is, and its effective interlock or equivalent. This is warning device and this emergency stop. So this is A. VC says take account of you can say regulatory equipment. Take account of regulatory equipment. What is this now? Let us get nonsense. Check the advertisement. Some kind of stupid. So here is shielded house is shown to you, and there is effective interlocking equivalent and warning device and control panel. This warning device is here and here, and this is emergency stop. It is control panel. Say take account of regulatory requirements, approved codes and standards, ensure protection to restrict exposures, and be designed to prevent accidents. This is enclosed area, you can say. Main entrance is there, and you can say take account of regulatory requirements, approved codes and standards, enclosure protection to restrict exposures, and be designed to prevent accidents. Designs of shielded enclosures require guidance in terms of anticipated doses, dose rates and exposure times. So designs of shielded enclosures require guidance in terms of anticipated dose rates and exposure times. Designs are to be based on LRA principle, as low as reasonably acceptable, and on whatever additional dose constraints that may have been specified, by regulatory authority. The design considerations for these installations include shielding considerations. Personal access door interlocks. First is shielding consideration, then it is personal access door interlocks, and fixed radiation monitors, warning signs and symbols, and emergency stops. An outline sketch is shielded enclosure shown in figure 13. So that's okay. Now shielded design for shielded enclosure. Shielding design for shielded enclosure. It is important to plan design of shielded enclosure for immediate and foreseeable future needs before commencing construction. Annotated drawings or sketches are prepared of installation and its surroundings, including dimensions, of each enclosed area, thickness, density and type of shielding material on all sides, including above and below exposure area. Entrances are identified and distances to potentially occupied area adjacent to above and below exposure area are indicated. Proper planning of facility minimizes cost of installation and avoids costly remedial work, which may be required if degree of protection necessary is not achieved in practice. Direct radiation exposure and scatter. Direct radiation exposure, direct radiation exposure and scatter from operation of shielded enclosures must be limited. Direct radiation exposure and scatter from operation of shielded enclosures must be limited by appropriate shielding. A competent estimate of thickness of shielded needed requires transmission graph, which are published for different radionuclides and X-ray machines. A simplified method to estimate shielding thickness is possible. Design principles are similar for all shielded enclosures, although different shielding characteristics are incorporated depending on whether shielded enclosure will be used for X-rays or for gamma radiations. Also, shielding design should consider both primary and scattered radiation and prevention of air scattering, sky shine in facilities with minimal or no roof shielding. Amount of shielding is to be calculated with reference to dose rates, use factor and occupancy factor. Some penetrations of shield shall be necessary for personal entry. Some penetrations of shield shall be necessary for personal entry and exit. Cranes to place and remove heavy objects to be radiographed, pipework, control cables, ventilation and other ducting. Radiation which either penetrates or scatters around weaknesses in shielding can cause problems. Such weaknesses might occur after a period of wear, shielding damage, movement of shielding or building settlement. Various design techniques can be used to prevent or minimize these weaknesses. When design of shielded enclosure has been established, no subsequent changes that affect radiation safety are to be made unless they are more effective and are authorized or approved by regulatory authority or a qualified expert recognized by regulatory authority to perform this function. Shielded enclosures are to be used within design constraints. Changes in radionuclide type, source activity, radiation energy and intensity may require a change in shielding provided. Documentation has to be kept showing results of calculations, radiation level measurements and maximum expected radiation levels inside shielded enclosure and in all areas adjacent to it. For shielded enclosures, appropriate instructions are provided at access points and other appropriate locations inside and outside control areas. Occupational radiation protection and safety measures are established. including local operating instructions and procedures that are appropriate for control area. Access to shielded enclosures is restricted by administrative procedures such as use of permit to work systems. Access doors are locked or interlocked for gamma radiography, and interlocked for X-ray radiography. Degree of restriction required is commensurate. Degree of restriction required is commensurate with magnitude and likelihood of exposures that would be expected. Control of exposure in shielded enclosures. A wide range of radionuclides, a wide range of radionuclides, source activities, and X-ray devices are used in shielded enclosures. What is that? Radionuclides, source activities, and X-ray devices are used in shielded enclosures. Type P, M, and F exposure containers are used as appropriate, containing one or more radiographic sources. Sources are kept secure to prevent unauthorized use, unauthorized removal or theft or damage to sources. If radiographic sources are stored in shielded enclosures, if radiographic sources are stored in shielded enclosures, it may be necessary to designate these shielded enclosures as permanently control areas even while no radiography is being carried out. Shielded enclosures are to be fitted with suitable safeguards. Shielded enclosures are to be fitted with suitable safeguards to ensure that people cannot gain unauthorized access to radiation room while exposure devices in exposed position or is energized. Access control relies heavily on use of interlock system. Suitable interlocks have to be installed to form a mechanical or electrical link between exposure control system and door or other points of entry to shielded enclosures. Redundancy, diversity, and independence of interlocks provide additional levels of safety. Redundancy, which means more than enough or more than required. Redundancy, diversity, and independence of interlocks provide additional levels of safety. Interlock either prevents a person from entering during an exposure, immediately interrupts electrical power to X-ray machine, immediately interrupts electrical power to X-ray machines, or automatically shields radiographic sources. Subsequent closing of interlock must not automatically re-energize X-ray machines or re-expose radiographic sources. Automatic exposure devices do not operate if interlock is open. For shielded enclosures, for gamma radiography, a radiation monitoring system with built-in redundancy is to be installed. For shielded enclosures for gamma radiography, a radiation monitoring system with built-in redundancy is to be installed. Radiation monitor is integrated with door interlocks. A radiation monitor is integrated with door interlocks to prevent entry when radiation monitor detects radiation in excess of preset level. Same installed radiation monitor also triggers visible and audible alarm system. Same installed radiation monitor also triggers visible and audible alarm signals. Such a system does not obviate need use a portable survey meter when entering a shielded enclosure. Emergency stop buttons or pull cords are to be installed to enable whoever person within shielded enclosures to quickly terminate or prevent radiation exposure. Radiation exposure. These are located so that they can be reached without passing through preliminary radiation. These are located so that they can be reached without passing through a primary radiation beam and are labeled with clear instructions on their use. Emergency control system is to be designed to allow people then to leave shielded enclosure or to summon assistance. Radiographer ought to be able to terminate exposure immediately in an emergency. Radiographer ought to be able to terminate exposure immediately in an emergency. Clearly visible signs bearing radiation symbol, international trefoil and warnings as required by regulatory authority are to be posted at all doors to shielded enclosure. Warning signs are made from materials that are durable under prevailing environmental conditions and are replaced as necessary. Visible warning signals have to be prominent and positioned in suitable locations. Audible warning signals have to be distinct. And loud enough to gain immediate attention of people in area. Warning signals are to be distinguishable and designed so as not to be confused with some other signals in use in area. Meanings of signals are to be explained in posted notices. Following illuminated or color-coded controls are to be used. Condition and color. Emergency stop buttons or lights. Red. Stop buttons or lights. Radiation on, no access. Red and international trefoil. Warning standby. Amber and international trefoil. Radiation off. Safe access. Green. Information below. Exposure control system for exposing a radioactive source or energizing an X-ray machine is to be located outside shielded enclosure. Exposure control system for exposing a radioactive source or energizing an X-ray machine is to be located outside shielded enclosure. Operating procedure for shielded enclosures. Only authorized workers who have received appropriate training are to operate shielded enclosures. If shielded enclosure is designated as a controlled area, it is appropriate for authorized workers to have had medical examinations and to wear personal dosimeters as specified by regulatory authority. These dosimeters include film or thermoluminescent dosimeters, personal direct reading dosimeters, and alarming dosimeters. So here guys, thermoluminescent dosimeters, personal direct reading dosimeters, and alarming dosimeters. Training includes instruction to ensure that shielded enclosure is used within its design constraints and that all aspects of facility are maintained to original specification. Written operating procedures have to be readily available as appropriate or required. Whatever changes to exposure devices or their use not considered in design of shielded enclosure may result in excessive dose rates outside shielded enclosure. In practice, this means that different equipment or modified work procedures are not to be used without careful safety considerations and authorization. A suitable portable survey meter has to be kept available to measure accessible dose rates outside enclosure. Measurements are to be made at positions above ground level at a distance from shielded enclosure, and in particular when radiation beam is operated at limits of shielded enclosure design parameters. Whenever radiographer enters shielded enclosure, has to carry a portable survey meter. Before using instrument, a check against a test source is performed to ensure that instrument is working. This procedure is necessary and additional to whatever radiation measurements made by an installed monitoring system. If it is desirable to use shielded enclosure for purposes not originally covered or intended under design specification in order to keep doses ALARA, such as keeping door open or using a gamma exposure device in an X-ray radiography shielded enclosure. And site radiography procedures are to be followed. This includes ensuring that dose rate at control point is less than 2 mSv/-1, and barriers and notices are set up to make whatever control areas near door or elsewhere. Before radiation source is exposed or energized, shielded enclosure is to be checked. Shielded enclosure is to be checked by radiographer to confirm that no person is inside. Exposures are to be initiated by radiographer only when door is closed. Exposures are to be initiated by radiographer only when door is closed, all essential shielding is in place, safety devices are in operation, and warning signals are given. Site radiography procedures. Site radiography procedures. Most radiography is performed on site and is influenced by a number of site-specific conditions. Planning for safe operation includes consideration of location, proximity of members of general public, weather conditions, time of day, and work at height. In confined spaces or under difficult conditions. Owing to these conditions, site radiography needs to be performed with more than one radiographer. A typical site radiography setup is shown in figure 14. Typical site radiography setup. Danger or don't pass. This is here. And you can say here so 1 2 3 4 5 6 all item. Boundary of control areas. Let us say site radiography needs be done. Site radiography needs be done in an area where specific protection measures and safety provisions are in place, namely in an area designated as a control one. Boundary of control area is to be set at a dose rate contour which is appropriate under prevailing circumstances and specific exposure times and is authorized by regulatory authority. This dose rate contour has to be set up at a value ensuring that outside control area annual dose limits for public are not exceeded. Account being taken of nature and frequency of site radiography at a specific site use as well as occupancy factors were allowed. Boundary dose rates when collimators are used, boundary dose rates when collimators are used are typically in range of 7.5 to 20 micron SVH-1. Boundary dose rates are typically in range of 50 micron SVH-1 when it's not possible to use a collimator. Transient dose rates during radiography source without operations will exceed these values. Transient dose rates during radiography source without operations will exceed these values. However, transient dose rates usually do not present a radiation protection problem as they occur only briefly. Boundary of control area has to be demarcated when reasonable, practicable. This is done by physical means. This may include using existing structures such as walls, using temporary barriers, or cordoning area with tape. Typical setup is shown here 14. Warning notices. Warning notices. Warning notices, this is here and it's now down by, still there. Warning notices are displayed at control area boundary at suitable positions. Notices are displayed at control area boundary at suitable positions. Notice bear International Radiation Trifield symbol, warnings and appropriate instructions in local language. Warning signals. In all cases, adequate warning is to be given, visible or audible or both, and used where a radiographic source is exposed or an X-ray machine is energized and surveillance is compromised. Use of visible and audible signals shall help to reduce likelihood of accidental exposures to radiation. Patrolling and monitoring boundary before a start of radiographic work. Area to be cleared of all people except for authorized personnel. Boundary should be clearly visible and well lit and continuously patrolled to ensure that unauthorized people do not enter control area if boundary is large or if it cannot be seen from one position or not secured by physical means. More than one person shall need to patrol area. Dose rates at representative points at boundary are to be checked during radiography. Particularly when position of radiography within area or direction of radiation beam is changed. Shielding. Shielding reduces both size of control area and radiation doses received by radiographers. Shielding in form of collimators is designed so that radiation beam is primarily in direction necessary for radiography. Collimators are made from depleted uranium, Du, tungsten or lead, and give tungsten or lead and give shape to beam. Beam shapes range from conical to panoramic annular. Beam shapes ranges from conical to panoramic annular. Collimators are supplemented with other forms of additional local shielding such as lead shots, sheets and bricks. Whenever it is possible to take advantage of existing shielding such as walls, vehicles or shielded enclosures or similar structures to reduce radiation dose levels. Radiography personnel need arrange disposition of equipment and parts within shielding afforded. Site radiography conditions are still applicable. Administrative arrangements. As possible use of engineering means to restrict exposure. As possible use of engineering means to restrict exposure during site radiography is limited. Proper management organization controls, operating procedures and training are very important. Unauthorized entry into control area is not allowed when radiation source is exposed. If possible, control point for initiation and termination of radiation is outside control area boundary. However, radiographer may have to enter control area to initiate exposure, leave area or move to a shielded location For example, where dose rate is less than 2 mSVH-1 and H2 power minus 1, and exposure time is short during exposure, and enter again to terminate exposure. Effective means of communication. Effective means of communication between radiographic workers are to be used in order to avoid unintended exposures. Such a situation can occur when radiographer operates device and radiographer changes films. In addition, effective communication reduces need for retaking exposures, thereby keeping close doses alarm as low as reasonably acceptable. Exposure devices on site have to be secured against unauthorized removal or theft when not under direct surveillance. Devices are to be stored in a locked area for overnight or temporary storage, as for example during work breaks. Monitoring. Monitoring. Personal dosimeters. Personal dosimeters such as thermoluminescent, thermoluminescent or film dosimeters, and direct reading dosimeters are to be worn when radiographers work with ionizing radiations. When radiographers working with ionizing radiation. A personal dosimeter is worn only by radiographers to whom it is issued, and is securely stored in a non-radiation environment when not being worn. Personal dosimeters are to be regularly assessed for radiation to which they have been exposed as required by regulatory authority. Direct reading dosimeters have to be periodically assessed by radiographers to monitor doses received during radiography. Portable survey meters. For site radiography operations, at least one portable survey meter has to be available for each working group. Before beginning radiography, meter is to be tested against a check source or by placing meters detector close to exposure container to obtain a reference reading which can be referred to during radiography operations. This ascertains reliability of instrument and confirms that radiographic source is in secured position. This figure shows use of an instrument to survey exposure device. Use of instrument to survey on exposure device. During radiography, primary survey objective is to determine that radiographic source has returned to shielded position or that X-ray emission has ceased for each radiographic exposure. X-ray emission has ceased for each radiographic exposure. Exposure devices have to be approached with portable survey meter switched on, since there is possibility of radiographic source being stuck in exposed position or X-ray exposure control having failed. Personal alarm monitors. Radiographers need use personal alarm monitors during whole period. They may be exposed to ionizing radiation. Alarm provides a recognizable signal at a suitable dose rate that may be prescribed by regulatory authority. Signal is to be audible, visible or vibratory, and recognizable in working environment. These alarms are used in addition to portable survey meters. Additional precautions for gamma radiography. Radionuclide and activity of radiographic source are selected such that dose for all workers is kept LRA as low as reasonably acceptable, consistent with obtaining adequate diagnostic information. It is possible to do most radiographic work by using iridium-192 with an activity of up to 1850 GBq brick 50 Ci. Advanced techniques are available such as image intensifying screens or fast film and screen combinations to keep dose LRA. Procedures need be rehearsed and only equipment that's specifically manufactured for gamma radiography is to be used. Radiographer needs to be familiar with all equipment, its mode of operation and potential problems. An understanding of source, its appearance and how it is to be exposed is particularly important. Radiography is only to be carried out when exposure container and all necessary equipment are available and in good working condition. Radiography is only to be carried out when exposure container and all necessary equipment are available and in good working condition. This includes portable survey meters and personal dosimeters. Guide tubes, control cables and remote control, collimators and local shielding, temporary barriers or tapes, warning notices and signals. Emergency kit including remote source, handling tools, other ancillary equipment such as clamps and positioning aids. Before leaving site, radiographer carries out a visual examination to ensure that equipment has not been damaged. Exposure container is made ready for transport by locking device and putting protective coverings in place. Exposure container and ancillary equipment are physically secured. Exposure container and ancillary equipment are physically secured in vehicle to avoid damage during transport. Following checks are made before use as described in operating procedures. Check exposure container and exposed ends of cables for damage, wear or dirt. A wear gauge supplied by manufacturer can be used. Check screws and nuts for tightness and screw threads and springs for damage. Confirm that source locking mechanism works properly. Confirm that source locking mechanism works properly. Examine end of pigtail for wear. Examine end of pigtail for wear, damage and proper connection to control cable. A wear gauge provided by manufacturer can be used for this purpose. Check connections between exposure container and cables for secure connection. Inspect all cables and guide tubes for cuts, breaks, kinks and broken fittings. Check warning label and source tag. Check warning label and source tag details for legibility. Measure radiation levels close to exposure containers. Measure radiation levels close to exposure containers surface for compliance with IAEA safety standards series number ST1 and to confirm that source is shielded. If whatever discrepancy is noted, equipment is not to be used until a replacement is provided or a repair is made. Additional precautions for radiography including use of accelerators. Procedures discussed in this section are applicable to use of X-ray exposure devices and techniques, including accelerators and real-time radiography. Selection of X-ray tube voltage is normally closely linked to requirements for quality of radiography. Exposure technique, namely source internal or external, single wall versus double wall, is selected with regard to a good image quality and reducing of dose for all involved. Following checks are made before use as described in operating procedures. Check for visible damage on all parts of equipment. Check X-ray tube and all exposed ends of cable for damage, wear, dirt and moisture. Check screws and nuts for tightness and screw threads for damage. Inspect all cables for cuts, breaks, kinks and broken fittings. Check exposure factor settings for legibility. If whatever discrepancy is noted, equipment is not used until a replacement is provided or a repair is made. Accelerators generate very high energy X-rays which increase potential for overexposures of radiographers. Therefore, higher levels of radiation protection are required on site. Dose rate in main beam of an accelerator is high and can range from 4 GY-min power minus 1 from a mobile accelerator to 50 mGy minus 1 from a portable accelerator. This means that dose rate around apparatus is much higher than during conventional X-ray radiography. And so much comprehensive control measures are needed. Restrict exposure of people to ionizing radiation. In addition, appropriate portable survey meters are used that respond accurately to pulsed nature of radiation field. Radiation pulse duration and pulse repetition frequency. Portable survey meters used for conventional gamma and X-rays radiography may not be suitable for use with accelerators. Additional precautions for underwater radiography. Underwater gamma radiography is a specialized technique that requires additional considerations. Appropriate training of divers is necessary. Appropriate training of divers is necessary. Before being taken into water, control mechanism and guide tube are to be connected to exposure container. Before being taken into water, container control mechanism and guide tube are to be connected to exposure container. Connections need be confirmed to be secure and source assembly has to be in secured position. A short line with a bio and an emergency location device, for example a strobe light, are to be securely attached to exposure device. This shall aid recovery from water if exposure container is dropped. A short line with a bio and emergency location device, for example a strobe light, are to be securely attached to exposure device. This shall aid recovery from water if exposure container is dropped. All equipment such as survey meters to be used underwater need be specifically suited for that purpose. Additional precautions for pipeline crawlers. General radiation safety requirements for X-ray and gamma exposure devices also apply to pipeline crawlers. With pipeline crawlers, useful beam is restricted so that its width is no greater than is necessary for radiography. When in use, pipeline crawlers are not visible from outside pipe. When in use, pipeline crawlers are not visible from outside pipe. It's thus essential that suitable warning signals are given. Warning signals of X-ray pipeline crawlers have to operate automatically. It is desirable that gamma pipeline crawlers also operate in this way where practicable, because unintended movement of control source may inadvertently initiate an unplanned exposure. Warning signals have to be capable of alerting people. Warning signals have to be capable of alerting people in vicinity of pipeline crawler under prevailing environment conditions. Signals that operate automatically are to be linked with operation of pipeline crawler. Audible signals are attenuated by pipe valve and need be loud enough to locate pipeline crawler accurately within pipe. Klaxons and sirens can be used provided that they can be heard in a noisy environment. Possible supplementary signals outside pipe include a visual signal to supplement audible signals in noisy environments, a radiation activated warning device that shall indicate position of crawler equipment along pipe, that is radiation activated warning device that shall indicate position of crawler equipment along pipe. Also, a portable survey meter is used to determine that X-ray emission has ceased or that source has returned to shielded position after each exposure. Personal alarm monitors. Personal alarm monitors. Personal alarm monitors worn by radiographers also indicate whether pipeline crawler equipment is emitting radiation by radiation nearby inside pipe. It says personal alarm monitors worn by radiographers also indicate whether pipeline crawler equipment is emitting radiation nearby inside pipe. If pipeline crawler breaks down, it may be necessary for a radiographer to enter pipeline to retrieve it. Before entering, a check is to be made by radiographer to ensure that pipeline crawler is not emitting radiations. If pipeline crawler breaks down, it may be necessary for radiographer to enter pipeline to drive it. Before entering, a check is to be made. Before entering, a check is to be made by radiographer to ensure that pipeline crawler is not emitting radiation, as pipeline potentially contains welding fumes and toxic gases, namely from pipeline crawlers, internal combustion engine. Checks are to be made to confirm that atmosphere is safe before entry into pipeline. Respiratory equipment may be necessary. Respiratory, so I repeat, if a pipeline crawler breaks down, it may be necessary for radiographer to enter pipeline to retrieve it. Before entering, a check is to be made by radiographer to ensure that pipeline crawler is not emitting radiation, as a pipeline potentially contains welding fumes and toxic gases, that is from pipeline crawlers, internal combustion engine. Checks are to be made to confirm that atmosphere is safe before entry into pipeline. Respiratory protective equipment may be necessary. Radiographic source, whatever, and control source are to be housed. Radiographic source and control source are to be housed in shielded container, and together with telltale source should not produce dose rates, in excess of 100 microsv into H per month on accessible surface of pipeline. Can say respiratory system may be necessary. Radiographic source and control source are to be housed in shielded containers and together with telltale source should not produce dose rates in excess of 100 micron SVH-1 on accessible surface of pipeline except during exposure. If pipeline crawler is kept in pipeline between radiographic exposures, a supervised or controlled area is set up around pipe. So we can say pipeline crawlers captive pipeline between radiographic exposures. Supervised or controlled area is set up around pipe as necessary. Control sequence to be designed so that when unlimited unintended exposure are prevented. Storage, movement and transport of radiographic sources and exposure devices. Storage of sources. Storage facilities are designed to restrict exposure, keep radiographic sources, exposure containers and control sources secure against theft or damage, and prevent all unauthorized persons from carrying out whatever actions which would be dangerous. Storage of sources. Storage facilities are designed to restrict exposures. Storage facilities are designed to restrict exposure, keep radiographic sources, exposure containers and control sources secure against theft or damage, and prevent whatever unauthorized persons from carrying out whatever actions which would be dangerous to themselves or to public. Storage facilities are designed to restrict exposure, keep radiographic sources, exposure containers and control sources secure against theft or damage, and prevent whatever unauthorized persons from carrying out whatever actions which be dangerous to themselves or to public. Clear warning notices are to be displayed at storage facilities. A suitable storage facility for radiographic sources, exposure containers, control sources and ancillary equipment is one that if outside of storage facility is accessible to public, shielding is provided to reduce dose rate in this area to less than 2.5 micron SV H by 1 minus 1 H power minus 1 as or as authorized by regulatory authority. Door is to be kept locked and if you can see now, door is to be kept locked and keys for storage facility and exposure device controls are to be held only one by authorized personnel. Physical inventory checks are to be made periodically that. So can say now physical inventory checks are to be made periodically to confirm location of radiographic sources, exposure containers and control sources, movement and transport of sources. When gamma exposure devices and sources are to be moved around a work site, they are not to be removed from storage facility until they are ready to be used. Sources are to be moved only in appropriate containers such as transport packages, which are locked correctly and keys of which are removed. When gamma exposure devices and sources are to be moved around a work site, they are not to be removed from storage facility until they are ready to be used. Sources are to be moved only in appropriate containers such as transport packages, which are locked correctly, and these are now what we say a vehicle or trolley is best used to move containers under these circumstances. Containers are secured to vehicle or trolley and are kept under surveillance for duration of movement on work site. A vehicle or trolley is best used to move containers under these circumstances. Containers are secured to vehicle or trolley and are kept under surveillance for duration of movement or on work site. Requirements for transportation of radioactive materials are published in IAEA Safety Standards Series number ST1 and other publications relating to specific modes of transport from organizations such as the International Civil Aviation Organization ICAO, International Civil Aviation Organization. Then main requirements spelled out in reference 17R. All transport and radioactive source should comply with containment. All transport of radioactive sources should comply with containment, labeling and documentation required and whatever existing national legislation. Provisions should be established. Provisions should be established to ensure compliance through appointment of a regulatory authority for transport of radioactive materials. Industrial radiography. Provisions should be established to ensure compliance through appointment of regulatory authority for transport of radioactive materials. Regulatory authority sets up and executes a program for monitoring, design, manufacturing, testing, inspection, maintenance, quality assurance of packages. Industrial radiography exposure containers should satisfy requirements of Type A or Type B packages for transport. A summary of requirements of these types of packages included Schedule 9 and 10 of IAEA safety sizes. Number 18. Operating organizations are often consignors, or operating organizations are often consignors or shippers of exposure devices to and from temporary work sites, and therefore So, gamma exposure devices are frequently transported by road by operating organizations. Drivers and vehicles must comply with applicable requirements. Of national and interstate roads. These requirements prescribe necessary safety equipment on vehicles, placarding, transport documentation, and training of drivers. In event of transport accident, vehicle driver, local emergency services, or whatever other person discovering accident shall contact package consignor and or consignee who are identified on the transport. Okay. In event of transport accident, vehicle drivers, local emergency services, or whatever other person discovering accident shall contact package consignor and or consignee who are identified on transport documentation. Both organizations are to be fully aware of emergency plans and provide or call for practical advice and assistance. IAEA Safety Series number 87 gives guidance and recommendations for dealing with transport accidents and is useful for preparation of transport emergency plan. Okay, now we go to emergency response planning. Accidents have occurred in industrial radiography resulting in workers and members of public being exposed to radiation. And another health. So, accidents have occurred in industrial radiography, resulting in workers and members of public being exposed to radiation and other health and safety hazards. Typical situations which have led to radiological hazard include loss of control of source or exposure devices, damage to source or exposure devices, and direct contact with source. Emergency resulting in exposures. Emergency resulting in exposures. Experience and analysis of kind described have shown that most likely event involving gamma exposure devices with great potential for significant radiation exposure to workers and general public concerns. This shows that most likely event involving gamma exposure devices are with greatest potential for significant radiation. Emergency resulting in exposures. Experience and analysis of kind described have shown that most likely events involving gamma exposures devices with greater potential for significant radiation exposure to workers and general public concern. Failure to retract source. Failure to retract source and failure to perform an adequate radiation monitoring survey. Source struck in guide tubes. Source stuck in guide tube, collimator or near entrance to exposure container. Source disconnection from camera cable. An exposure device stuck in exposed position, such as a shutter remaining open. Theft of exposed device or source assembly. Malfunction or deliberate defeat of safety control system. Contamination due to leaking or damaged source. I repeat. Failure to retract source and failure to perform an adequate radiation monitoring survey. Source stuck in guide tube, collimator or near entrance to exposure container. A source stuck in guide tube, collimator. So first is failure to retract source and failure to perform an adequate radiation monitoring survey. A source stuck in guide tube, collimator or near entrance to exposure container. Source disconnection from camera cable. An exposure device is stuck in exposed position, such as a shutter remaining open, theft of exposure device or source assembly, malfunction or deliberate defeat of safety control system, contamination due to leaking or damaged sources. Most serious exposures occur where the worker remains next to or physically handles unshielded source assembly. When source assembly is missed, most serious exposure occurs when a worker remains next to or physically handles unshielded source assembly. When source assembly is mishandled or when it is in possession of members of general public, dose rates are high enough to cause localized overexposure. Overexposure in a matter of dose rates are high enough to cause localized overexposure in a matter of seconds or minutes and can result in severe injury and even death. Most likely events involving X-ray exposures devices and potential for significant exposures to workers are: an automatic exposure timer fails to terminate an exposure, resulting in, tube assembly remaining energized. An outcome: exposure time for failure to terminate tube assembly is energized unintentionally. Operator neglects to terminate exposure and fails to perform an adequate radiation monitoring survey before manipulating tube assembly. There is damaged, faulty, or deliberately defeated safety equipment and systems such as malfunctioning interlocks. Physical damage affects shielding or filtration. Emergency planning and preparedness. Emergency planning and preparedness. Emergency planning and preparedness has four major components: assessment of hazards, acquisition of emergency equipment, development of written procedures, and training to deal with emergency situation, including training in handling of emergency equipment and following written procedures. Basic obligations, responsibilities, and requirements of emergency situation are established in safety series. Advice and guidance on development and implementing emergency plans are provided in IAEA safety series. So let's hold back here now. Let us go back. Emergency planning and preparedness. Emergency planning and preparedness has four major components. One is assessment of hazards. Assessment of hazards, acquisition of emergency equipment, development of written procedures, and training to deal with emergency situations, including handling of emergency equipment and in following written procedures. Basic obligations, responsibilities, and requirements for emergency situations are established in Safety Series number 115. Advice and guidance on developing and implementing emergency plans are provided by advice and guidance. Basic obligations, responsibilities, and requirements for emergency situations are established in Safety Series number 115. Advice and guidance on developing and implementing emergency plans are provided in IAEA Safety Series number 91 and step-by-step method for developing integrated user, local and national emergency response capability set for IAEA Tech Talk. So this is what we could discuss today about radiations. Remaining points we'll discuss next time, because people should understand also. It's not simply reading. It's dress, means we should know what we are reading. It's not just announcement, but it is that we have to understand. It's like a textbook we read. It's more than text, in fact. It's more than text. Because we have to understand our radiographic talks, X-ray, gamma rays such as iridium 192, iridium. We have to go through all this, and that only we can understand. Point, I think we should understand that, and it's called quality understanding. It's called quality understanding, and that's a very important point. You can say that whatever we understand with clarity, complete clarity, with not even not even a point degree lapse in that understanding. That's the reason we could say move like this, and we'll see what else is there. There are some more important talks here with many portfolios and sources. Sources are very interesting. International Atomic Energy Agency, Food and Agriculture Organizations of the United Nations, international, so many are there. Next time it will be concluding statement only. A few pages left. We are on 58 page. So now I think we should have a closure of this now. It's time now. But if we have a closure of 3 hours already gone, so better is to close it for next time. That's only way we can move. Thank you very much.